we're going to look at some dating methods. And whenever I've talked about archaeological dating methods, I've always made some dumb dad jokes. So I'll refrain from that now. But we're going to look at how you can actually date different objects, the pros and cons of the different systems. You guys will get to try some things on your own. There's more to archaeological dating than just radiocarbon or C14 dating. So we're going to look at the different types. We've already done something with frequency seriation when you looked at the Marblehead Cemetery. We'll review a little bit of that. Stratigraphy is a dating method. So as we said before, it's a relative dating method because you can tell if something's older or younger, but not how much. We'll talk about cross dating, historical dating, dendrochronology, and then scientific dating techniques. Okay, so seriation and stratigraphy are both relative dating techniques because you are able to say relative to this, B is younger. Relative to that, C is older, right? That sort of thing. But you don't actually get a date in calendar years. That is absolute dating techniques like C14 dating, where you're getting a number date. We're going to look at some of these absolute dating techniques first. Okay, one of the first ones we'll talk about is cross dating. We'll look at dendrochronology, radiocarbon dating, potassium-argon dating, obsidian hydration, thermoluminescence, and archaeomagnetic dating. Right? All of these have sort of benefits and drawbacks, and archaeologists don't depend typically just on one. They try to use a combination of dating techniques because the more different techniques you use, the more accurate your date will probably be. Okay, let's look at cross dating first. So cross dating, what you're doing is you're dating a level, let's say a stratigraphic level, by referencing an artifact or an object in that level that has an established date. Right? So it could be something like the pottery in an area has been so well studied that when you find that pottery in that level, you have a pretty clear date. Maybe not as accurate as within a 50-year range, but maybe within, let's say, a few 100-year range. Or lithics, right? So projectile points in North America. When you find these projectile points, you have a pretty good idea of a approximate date for that site or for that level. Coins, of course, will give you a good date to the year. And the Maya also dated their stone monuments, right? In the Maya calendar, they have a long count that is essentially equivalent to our years. So when you find a Maya stela, you're able to date it. So ancient calendar dates, pottery, lithic chronology. Again, chronology is just the study of time. A chronology is just a sort of a layout of the different types of artifacts and when they date to. And coins. Okay, when we talk about dating techniques and really any kind of scientific technique, one of the things we need to mention, of course, are the principles of accuracy and precision, and they're not the same thing. Accuracy is how close a reading is to the actual result, right? So if you got on the bathroom scale, let's say you know already that you weigh 135 pounds, you get on the bathroom scale and it says 136, okay, my bathroom scale home is pretty accurate. That's very different from precise. Precise is how close are repeated measurements, right? So you could have a bathroom scale that was not accurate, but very precise. So you could get on the bathroom scale, and the first time you get on, it says 160. Next time it says 159. Next time after that, it says 161, and then 160 again. You would say, wow, this scale is very precise. It's all within, a pound measurement, but it's off by, 25 pounds, right? So a good way to think about this is to sort of think about a target. High accuracy, high precision, right? Everything is in the bullseye. So everything is close to the actual value, and all of the points are clustered. Each measurement is close to the previous measurement. Low accuracy, high precision. So this would be like that bathroom scale again. You're off by 25 pounds, but the measurements are very, very close to each other. High accuracy and low precision, right? So this would be something like you get readings like 132, 137, 130, 138, right? So it's all within, let's say, a range of 10 pounds. It's not very precise, but they're all clustered around the actual value. And then, of course, is the worst is low accuracy, low precision, all over the place, and all the readings are off. Okay, so the first one we'll talk about is dendrochronology. Dendrochronology is a very useful scientific technique. Dendro, trees, chronos, right, time, and logos, the study of. So the study of essentially tree time. You use tree rings in order to date a piece of wood. How do you do that? Well, in most areas of the world and most trees, a new ring is put on each year. And the new ring in the cut of a tree consists of a light band and a dark band, is one ring. So essentially, you're looking at one ring per year. You can count back the rings. So if you knew this tree was cut down, let's say last year, you could count the rings back and figure out when that tree was planted or where the earliest ring is. Now you can see that this only works, or one of the principles of dendrochronology is that the rings are different thicknesses, and that relates to precipitation during that year. So a very dry year, you're going to have a thin band. A very wet year, and you're going to have a thicker tree ring. Right? Now, it's these thick and thin bands that produce a unique pattern. Now, what this allows people to do is to take a piece of wood, look at the tree rings, and find an older piece of wood, find where they match up, and now you've got the rings going back to, let's say, 1871. Well, if you have a roof timber from an old house that's taken out, and you can match up some of the rings, then you can extend that sequence going back even further. And if you can do that, and sometimes the way this is done is by taking very old trees and boring a core into the tree so the tree is not harmed in any way, and then to take that core out, now you've got a record of the rings there. We're going to see that this is not only important for dating, but also for another important archaeological technique that's also used in other scientific fields. But then once you're able to overlap the rings, you have a record of the tree rings going back sometimes hundreds of years, sometimes in some areas of the world thousands of years. And then if you find a piece of wood from an archaeological site, you can then match it up to the master sequence and try and determine where it matches best and what the last ring is, and that's when the tree was cut down. So in order for this technique to work, you have to have several things. You have to have a master sequence for the area. Obviously, every single area of the world is going to have a different sequence. So you can't use the sequence in New Mexico for trees that are found in archaeological sites in Michigan. You have to have a local sequence. You can't have gaps, right? You have to be able to have any space filled by tree rings, right? But this technique has been done all over the world, and so now we have a good record going back, in some cases, as we said, thousands of years. Now, the other important aspect, right? So here you can see here's a sample, and here's, let's say, part of the master sequence. So you try and figure out, okay, where would this match up best? And you would determine it matches up right here best, and 1515 is the last ring, so that's when that tree was cut down. But as we're going to see, not only are you able to date a piece of wood, but you also have a record of climate data going back hundreds or thousands of years, right? That is, you can measure the rings, and you guys, I think we'll get to do this in a couple of weeks. You can measure the rings and estimate the precipitation for that region for that year. So you can then correlate that with certain other things, like the collapse of a state or civilization, or the beginnings of a new culture, right? That is, you might be able to correlate, for example, a harsh drought with the collapse of a civilization, and create this hypothesis that maybe that severe drought caused, or was one of the causes for the collapse of that civilization. Okay, so dendrochronology is a very important technique. I tried to use it in part of Canada. I did an excavation at a house that had burned down, and all the debris was knocked into the cellar. But it was supposed to be one of the earliest houses on this part of the eastern coast of Nova Scotia. And we wanted to see if it dated to the time of the English settlement, or if it was even older and dated to the time of the French settlement. So we actually this is a painting of the house when it stood, and it still stood until the 1990s, believe it or not. It was probably built, we think, based on the style of the architecture, probably in the early 1800s. Now, we found charred wood, but nothing that had enough rings, unfortunately, to allow us to do any dendrochronology dating. So you have to find a piece of wood that's big enough, not just a small fragment. It's got to be something like a roof beam that has several rings on it that you can match up. All right, so there are advantages to tree ring dating. It's pretty low tech. The other thing is you can get a date to the year, right? So, ostensibly, if you date that roof beam to 1789, you can potentially date the structure. Well, at least you know the roof beam is from 1789. Was the structure from 1789 as well? That's where things get a little iffy. But you can get a date to the year. Once you have this record, you don't have to have something like a mass spectrometer or high-tech equipment to do this, right? You just have to have a good lab space with good microscopes and things like that. Okay. There's some limitations, though. Right? Okay. You have to do this in an area where there's fluctuation in rainfall. If, let's say, it's a very tropical environment and the area gets basically the same amount of precipitation each year, the rings are going to be too similar in thickness to really tell the difference between them and to match up, let's say, a piece that you have from an archaeological site. The sample, again, as I said, has to be large enough so that you can match the rings up. You have to have a good preserved piece of wood, so charred wood. Right? This is something that a lot of non-archaeologists, it's counterintuitive for them. They would think if there's a fire in an ancient house, that it would completely destroy all the wood, and it would be much better to have an unburnt house. Ironically, it's much better to have a burnt house, because in the burnt house, the wood might be charred and actually preserve better than, let's say, wood that is fresh, has moisture still in it, and then decomposes in the soil. Right? So charred wood or waterlogged wood, like in a bog, will preserve well. There are sources of error, though. If you think about it, what could go wrong with a dendrochronology date? Well, I talked about the roof beam, and I said, you can date the wood to 1789, but does it mean the house dates to 1789? Not necessarily. We saw this in the Middle East. Wood is recycled. They may have took that roof beam from an earlier structure. The actual house may be 20 years later. Also, when people are using wood, they shave off the bark, and they may shave off outer rings. They're essentially shaving off years and giving you an older date. The sample might be so small that actually matches up on several locations, right? And that is a big problem as well. Well, I'm going to give you a chance to just do a little bit with dendrochronology. This is sort of just a very simple kind of try it problem. And that's is something I'm going to work on in the future in terms of developing more problems like it. Okay, so one of the labs that you guys will do a try it problem, it's more accurate. Here you can see a sequence of tree rings. This is from the Southwest United States. And what you're going to try and do is match up this sample with these rings, right? So you're going to see where it fits the best. This is the bark. This is the pith, right? So this is the last ring on this sample. Try and match it up and try and see if you can then figure out when this sample dates from. You can see I have some of the rings labeled in terms of the years. You'll see it goes from about 750 to 900 AD, the way people mark the tree rings. And you can, to make this easier, you can, on the bottom of Word is a little plus and minus to zoom in and zoom out. You can just take this piece and start dragging it along and see where it actually matches up the best. Every 50 years gets 2 dots, every 10 years or every decade gets a dot, every turn of the century gets 3 dots, right? So you can see 3 dots for 800 AD, 2 dots for 850, and in between 1, 2, 3, 4. Right? So that makes it just a little bit easier to read the rings. So you'll see the color's not exactly the same, so you have to really do it by the rings. And let's see how you guys do with that. Okay, so we'll talk about some more dating techniques. I'd like to introduce the topic of radiocarbon dating or C14 dating with a story about Piltdown Man. Some of you may have heard of this famous find. It was made in 1912. It was supposed to be an ancient hominid, ancestor to modern humans, found by Dawson. You can see over here in southern England. It was a huge deal at the time because it conflicted with all of the information that was coming out of South Africa. The information from South Africa was showing that South Africa was the place where hominids developed, and that with these ancient hominids, bipedalism, or walking on 2 legs, came first, and the large brain of humans came later. What this find seemed to show is kind of the reverse. It had the jaw was more primitive looking, but it had a large brain. So based on this, people were claiming that early humans arose in England. Early humans, a large brain developed first, and then the rest, bipedalism, came later. And a lot of people were very skeptical of this find because it contradicted all the other evidence that was being discovered. And not too long after Piltdown Man was first found, many people thought that this was in fact a forgery. But it wasn't until radiocarbon dating that people were actually able to prove it without a shadow of a doubt. Because when they dated the jaw, and it didn't fit perfectly into the skull, it was fragmentary. But when they dated the jaw and when they dated the skull, they got 2 different dates. Right? They're separated, I think, by 100 years. So there's no way this could have been one organism. Right? And in fact, what it was was a skull that was taken from a cemetery, probably a monk's skull, and a very old orangutan jaw that was just kind of filed down so that it sort of fit into this well, and both were stained using kind of like an iodine stain to look older. So it was a complete forgery. There's debate about who actually committed the forgery, but what is clear is that scientific dating techniques like radiocarbon dating help prove without a shadow of a doubt that in fact it was a forgery. So radiocarbon dating developed in 1949. It was an outgrowth of research into isotopes, into radioactive isotopes, and not too surprisingly, this is an outgrowth of the Manhattan Project, the development to build the first atom bomb. Scientists became very good with working with radioactive isotopes and understanding half-lives and how they work and all that. So let's look at how C14 dating works. Okay,